Good afternoon, and welcome to the session on migrating your data warehouses to Amazon Redshift. Fourth day, so I'm sure you have a lot crammed in here, so we hope to make it a little bit easy on you. My name is Pawan Pothukuchi. I lead the product team for Amazon Redshift, and I'm happy to have with me today Ali Khan from Scholastic and Lakshmi Maladi from North Bay Solutions joining me in the session. So before I proceed, a quick show of hands. How many of you already use Redshift here today? Okay, about a third. So that's helpful. So I'm going to start with a brief introduction to Amazon Redshift, and then discuss a few use cases of customers that have migrated to Redshift, the benefits that they've gotten, and go over a few options on tooling that can help you migrate to Redshift. After that, Lakshmi and Ali are going to dig deeper into Scholastic's use case, share their data platform architecture, some of the steps that they've followed to migrate to Redshift, and some of the learnings that they've had through the process of migration. So what is Amazon Redshift? So Redshift makes data warehousing faster, simpler, and a whole lot cheaper than before. It's a relational data warehouse. It's based on a massively parallel processing architecture with columnar storage. So it distributes and parallelizes all of the data warehousing operations that you care about: loading data, executing queries, backups, restoring from backups. It's also very easy to get started. You can create a single node cluster with 160 gigabytes of data in under a couple of minutes, and then scale it to terabytes or even petabytes with a few clicks on the AWS management console. It's a managed service. So what that means is a lot of aspects related to the heavy lifting of operating data warehousing infrastructure can be offloaded to the service. So this includes data replication across nodes, backups, automated and continuous backups, patching, disaster recovery, fault tolerance, and aspects like that. It's pretty cheap. You can get started with at 25 cents per hour, and all of this is available at a starting price of $1,000 per terabyte per year. Which is at least an order of magnitude cheaper than other data warehousing solutions in the market. So how has Redshift done so far? So here is an analyst view. So this was, the service launched about 3+ years ago, and Forrester rated it as one of the leaders in the data warehousing landscape. So the team delivered over 140 features, meaningful features, since the service got launched, which is roughly about 3 features a month. And have seen quite a lot of customer momentum, and Redshift is in fact one of the fastest growing AWS services in the history of AWS, right after Aurora. So here is a quick selection of Redshift customers. So we have customers across industry segments and sizes here. So customers such as Yelp that are loading tens of millions of ad impression data, and over 250 million mobile events data a day. They analyze ad campaign performance, how their users are using respective mobile features. NASDAQ is another example, and you have heard from FINRA yesterday at the keynote. So NASDAQ's use case is somewhat similar in that, of course, they operate across 100 exchanges in many countries in the world. They load over 8 billion rows of codes, orders, and trade information into Redshift every day, and analyze client activity and fraudulent patterns. So NASDAQ is an example of a customer that migrated from a different data warehousing solution to Redshift, and so did many more customers on this slide. So why are customers migrating to Redshift? So there are, at a high level, 3 broad use cases. So the first use case is a lot of customers start with using their transactional systems to analyze data, and they work pretty well. You can create a replica and analyze data, run reports on it. But as the data set size grows into terabytes range, performance start degrading pretty rapidly. And so these are the kind of use cases where customers found Redshift to perform over 2 orders of magnitude better. One of the other aspects of operating a transactional environment is that you're likely dealing with a single node or probably a couple of nodes if you're using rack. So you're constrained by storage, you're constrained by the amount of memory and CPU, and you have to vertically scale, so it gets pretty messy. Another class of customers that are migrating are the ones that are already using other MPP databases. The reason that they find Redshift appealing is that it's an order of magnitude cheaper. It's also, like we discussed, a managed service. So it enables them to offload the operational overhead of managing databases to Redshift, and they're able to deploy their developers, their administrators to more productive business intelligence application development. So the last one is a set of users that are migrating from using SQL on Hadoop into Redshift. And so the benefit there for them is it's an order of magnitude faster. And the end users don't have to learn programming. The SQL syntax is pretty familiar to what they're used to. Redshift offers standard JDBC, ODBC interfaces. So the ETL tools, the data integration tools, and the reporting tools that they use can be seamlessly used with Redshift. Quickly, some use cases here. Boingo Wireless, you may be familiar. They operate over 1 million hotspots and Wi-Fi locations across lots of countries. They've used an Oracle database, which they were using for transactions for analytics. And they found several limitations as the data set size grew, performance issues, the limitation around vertical scaling, administrative overhead, and expensive licensing cost. So they considered a bunch of options and found Redshift to be a fraction of cost. Compared to their existing solution, it performed over 2 orders of magnitude faster. So loads were used to be a couple of hours before for loading 1 million records for them, and that reduced to 15 seconds, which is significantly faster. Querying data used to take 45 minutes, and that reduced to 15 seconds as well. And so why is this the case? So we talked a little bit about the MPP architecture, ability to parallelize, distribute queries, data loads. So that is certainly part of the reason. Other reason is that Redshift offers columnar storage, automatic data compression. It comes with large data block sizes, a megabyte, and then local storage. So all of these lead to significantly less significantly less I/O required to perform queries compared to row-based stores. And the last reason is that Redshift runs on I/O optimized hardware. So you can get up to 4 gigabytes per second per node of scan rates with Redshift. And with enhanced networking, we are able to process over 1 million packets per second per node. So all of that leads to better performance. Another example of a customer that migrated from an MPP database is DoCoMo. So for those of you that are not familiar, they are the largest mobile carrier in Japan. They have 68 million subscribers. They generate tens of terabytes of data per day across all of their mobile network. And their use case is largely around analyzing this data to optimize their logistics, to optimize their marketing operations. And so they were using a Greenplum database on premises. It was, as you can imagine, fairly large footprint, and it was quickly getting pretty complex for them to manage it, both from a cost perspective as well as a management perspective. So they migrated to Redshift and found it to be not only cheaper, but an order of magnitude faster for their analytics queries compared to their Greenplum environment on premises. They also were able to free up a lot of time for their developers and reduce their BI application development time by 50%. So another example is Yahoo. So they have migrated some of their workloads from using Hadoop on SQL on Hadoop to Redshift. So Yahoo, as you know, operates lots of properties across mobile and web, and so they generate a lot of data across these properties. So for one workload, on an average day, they have 2 billion events spread across 25 million devices. And so they were using Hive. And as you may be familiar, Yahoo is sort of the source for the Hadoop movement, right? So they have created a lot of initial technology for Hadoop. So it's interesting that they found Hive to be difficult to use. They migrated to Redshift and found significant improvement in performance, similar to some of the other use cases. They were able to serve real-time insights, near real-time insights to their end users, and of course, the operational footprint is significantly lesser. So here is a quick analysis that they did with SQL on Hadoop technology and Redshift, and the y-axis here is in exponential scale, so the gaps here are pretty meaningful. So how do you quantify the business value and productivity that we talked about before? So for those of you that might need to convince your business or management, so IDC did a study recently with multiple Redshift customers that have migrated tens of terabytes and hundreds of terabytes of data into Redshift. And they found that the investment that these customers made broke even in 5 months, which is pretty compelling. So the kind of productivity benefits that they were getting were fourfold. They were able to analyze a lot more data than ever before. They were able to deploy applications like we discussed with some of the customer use cases much faster, faster time to market. They were able to get much better insights from their data because the queries perform much more quickly. And of course, with cloud, you're able to map your demand of applications with the capacity, so that helps with managing costs better as well. So how would you migrate to Redshift or any database for that matter? So there are multiple steps, right? So you have to map your data types from your source database into the target database. So in the case of Redshift, you also have to think about compression, given it's a distributed database, how do you choose the distribution keys and sort keys? And you need to generate the associated DDL, apply it on the Redshift side. You'll also then need to look at your ETL scripts, your reports, scripts that might be using ad hoc SQL, and convert that. You'll also need to assess the gaps because each of these engines come with different functions and capabilities. So what are the differences and how do you address these gaps? And lastly, you have to migrate the data. And that involves bulk uploading, the initial set of data. You might also need to capture updates on your source system while you migrate, or possibly even after the migration, if you're using transactional systems. So change data capture and applying that on Redshift will be necessary. You might also need to do some transformations if you're going from a transaction system to a fact dimension-based model. So that is important as well. So this might sound pretty complex. However, we have tools within AWS as well as our partner ecosystem and services that can help ease the process of migration. So I'm going to quickly touch upon a few tools, and there are some sessions which kind of go into more details with respect to these technologies. So AWS Schema Conversion tool can help you convert from a schema in your source database to Redshift with a few clicks. We had support for Oracle and Teradata. We recently added support for Netezza and Greenplum. So what this tool does is it generates a schema. It also looks at your source data and source database and the workload associated with it, cardinality, statistics, and figures out what are the optimal sort keys, distribution keys that you need to apply. On the Redshift side, it can help you convert SQL code that's part of your scripts. Lastly, it also generates a detailed assessment report that can help you look at things the tool was not able to convert, which is pretty important, and then so that you can figure out a way to do it yourself or through a partner. So a quick UI of the conversion tool. On the left-hand side, you can see the set of database objects corresponding to your source database. And on the right-hand side, there are database objects for Redshift. So you can pick and choose the objects from your left-hand side and then either convert them one by one, or you can do it across the board at once. In the center pane on the top, There are a set of issues that point out the gaps and why the tool was not able to convert specific objects. And below, for the objects that have been converted, you can see DDL code on the left-hand side for the source database and DDL code for the target database. So this covers the first three steps for conversion that I discussed earlier. You also need to convert your data. So the data migration service is another tool that can help you do that. There are several sources, including many transactional databases, including Oracle and SQL Server. You can do both bulk upload as well as capture incremental updates and continuously replicate to Redshift using this service. It's pretty cost effective at $3 per terabyte of data that gets migrated. It's also fault tolerant. So there is a replication instance that you'll need to use to buffer the updates coming from the source system. And then you can apply that on the target system, and the tool takes care of that. You can also make the replication instance HA so that if you're doing continuous replication, it's more resilient. Apart from the AWS tools, there are several data integration partners that help with data migration as well. So you have Informatica, Talent, Matillion that can help with the process. So you have system integrators that have capabilities and skills to migrate to AWS, as well as Redshift. NorthPay Solutions is one of them. So beyond Redshift, AWS also offers you a broad and deep ecosystem of big data services. So a couple of them got announced today. Glue, a bunch of them got announced yesterday in the AI space. So one of the things to consider here is that for AWS, S3 tends to be the center of gravity for all of our data. And so you ingest your data into S3, and lots of processing and execution engines and analytics engines can read the data sitting in S3 and help you make sense out of it. One of the design patterns that we are increasingly seeing is the usage of EMR and Spark to process, to perform ETL jobs, and then load the resulting data. So Spark has a Redshift connector that can load that data into Redshift, and you can use that for faster processing of SQL queries. So with that, I'm going to turn it over to Ali. So he leads the data and analytics group at Scholastic.
Thank you, Pavan, and good afternoon to you all. My name is Ali Khan. I'm responsible for data platform, business intelligence, and analytics at Scholastic, and I'm going to tell you the story of how we moved our data platform to AWS. But before I do that, can I just get by a show of hands, how many of you heard of Scholastic or are a customer or know what we do? Okay, most of you. So that's great and not surprising, right? If you have children who go to school here in this country, or you went to school in this country yourself, or you're a fan of the Hunger Games or Harry Potter, which are some of our more popular titles, then you're probably aware of Scholastic and what we do. We're a bookseller, basically. So what I want to talk about is some of the things that people commonly are not aware of. And the first thing that tends to surprise people is that this company was founded in 1920. So this is a 96-year-old company. And if you think about all the changes that have happened in the world, since then, that's pretty remarkable. This company started from a single magazine that was hand-delivered to a school to now being the world's largest publisher and distributor of children's literature. The second thing that tends to surprise people is that we're known for being a bookseller, but we're also a premier provider of educational tools. So we support school teachers in over 90% of the schools in the US to really help them in the classroom and really help drive them to improve their interaction with the kids. So from a data perspective, this puts us in a unique position. No one knows more about the reading habits of children and the experience of school teachers in early childhood literacy than Scholastic, not the government, not the schools themselves. So that's an amazing data set to have. And our challenge in data and analytics is really to help leverage that for the business so that we can help drive the core mission of improving childhood literacy. So where were we? So this 100-year-old company has been using computers for about 25 years. And about 13 years ago, we stood up our first enterprise data warehouse. And this is in the IBM AS400 platform, which looking around probably predates many of you. This made quite a lot of sense at the time because a lot of our source systems were, and actually still are, based on the IBM AS400 DB2 platform. However, it was discovered that it was quite challenging to get meaningful reporting data out of that platform. And so about 10 years ago, it was decided to build SQL Server as a layer on top of that initial data warehouse. So, this made a lot of sense as well at the time because there was the capacity to leverage SQL Server analysis services, right, which is their OLAP cubes, SSRS, SQL Server reporting services, which is a reporting solution, as well as end-user BI tools that were popular at the time. So, over the last 13 or 14 years, the enterprise data warehouse at Scholastic has become the sole repository, really, for operational reporting, for analytics. It's become key to the operations across every line of business. So we have 500 direct users, and by that I mean people who actually log into the enterprise data warehouse for their key metrics, and then we have probably twice that number of indirect users. And by that I mean people who have consumed data from the enterprise data warehouse into spreadsheets or other constructs and use that independently. So our problem isn't really scale or size of the data, right? So we started with a 20 terabyte data, which is small by today's standards. Our problem was in the complexity of taking data from many dozens of AS400 systems, SQL Server systems, and others, and really applying complex data logic and putting that into a form that was useful for the business. So every night we have thousands, over 5,000 jobs that run on the IBM platform. We have hundreds of jobs that run on the SQL Server platform. And after a while, this began to take a toll. For those of you who are familiar with data warehouse architecture, this is a very Kimball-esque type of design. And so that was fine for the time. But over time, some shortcomings have become apparent. One of them is the design methodology really dictated that the data was instantiated in multiple tiers, ostensibly for good reasons. The same data in different, for different reasons, right? So we had the staging data, we had the core enterprise data warehouse itself, we had data marts on top of that, and cubes that are on top of that. So all of these things were done for good reasons, right? There were concerns around performance or integrity, but this led to lots of issues. First and foremost, really the complexity environment inhibited us in terms of our time to market, right? So every time you need to make a change, you now need to make that change at several layers of the design, right, and test that as well. The complexity of the ETL processes led us to not be able to meet our SLAs with any real confidence. We also had reached some scale limitations with our cubes. The cubes were a great idea, right? So a cube is a pre-aggregated, multidimensional view of your data that once it's built, you can slice and dice to your heart's content and get instantaneous results. But that's the key point, once it's built, right? So our cubes would take 10, 12 hours to build. And all of these factors, all of these limitations led us down the path of not being able to provide effective self-service. So that's important, for if you run a data organization, you don't want to be a group of report writers, right? You want to emphasize to your users that you own the data, we're engineers, we're going to help you. But if you're not able to build a platform that does that, then you're going to end up writing reports for them, and that is not the correct model, nor is it a scalable one. So we're quite fortunate at Scholastic in that our management sort of decided to do a transformation of technology across the board. And data is one of those pillars. So we had the opportunity to kind of reimagine how we would build our platform, and we in fact did. So we thought about what are the key factors that really go into deciding what the new platform should look like. So at the top of our mind was the non-functional requirements, right? We had a platform that was not performant, not scalable or particularly available, and so we really wanted a design that would help overcome those challenges for the reasons that I mentioned around not being able to provide self-service. But we also wanted to leverage the very strong skill set that we had in data warehouse disciplines. So we have a team that understands a lot about what it takes to take data from these antiquated systems, apply business logic, and do that with a high level of data quality. So we really wanted to shorten that learning curve and leverage the skill of the team. And this is a team that knows relational databases really well. They think in SQL and so on. We also needed to integrate with existing technology. So whereas our area was undergoing a transformation, there are other parts of the enterprise that are already well established, and we wanted to make sure that we could integrate well with those. At the same time, Scholastic had embarked on a sort of a new paradigm for itself that was cloud first. So last year at this event, my colleague Jeff Gelb, who is here, he is the head of cloud and foundational engineering at Scholastic, talked about the fact that we were embracing this DevOps model and talked about that we had a number of initiatives that were really going to go cloud first, and data is one of them. So what I'm talking about today is really the progress that we've made in that 12 months since Jeff was here. Another one, really important for us, is the ability to support big data type initiatives. So this is key, right? Our industry, like many others, is undergoing profound change because of the digital revolution, right? So we sell books. So when we sell books to a physical bookstore, what do we really know about that transaction from a data point of view? Well, we know which book it is and when it was sold and how much it was sold for, and that's about it. But now that we have e-readers, right, that gives us a tremendous amount of insight into the behavior of that child that we didn't have before. So what is this child reading? How fast are they reading? Are they skipping parts? Are they highlighting words that they don't understand? So this data is just something that we really want to leverage to be able to improve the customer interaction and also optimize the product. And finally, we also wanted to make sure that we teamed up with a partner that really had sort of done this before and that could guide us and had been through this journey, because a lot of this was new for us. So, why did we choose AWS and Amazon Redshift? Well, Pavan recounted, some of the advantages and so on, so I'm not going to go through all those. But I just want to point out the things that really, really kind of struck us. The first was obviously our concern around meeting non-functional requirements. This is a platform that was scalable and fast, off the bat. Also, from a cost point of view, we would have a level of insight and control into managing the cost that we never really had with our previous platforms, and that was very attractive. And finally, this was quite familiar, right? So my own background is heavily in Teradata. So when I looked at Redshift, I said, oh, this is an MPP database, but it's column-oriented and it's in the cloud. So here's something that we can understand. My team, who are all trained in relational databases and classical data warehouse theory, quickly understood what this is, right? And that significantly shortened our learning curve. So also, then we partnered with North Bay, an Amazon partner who had a lot of experience in migrating to the AWS platform. Okay, so once we decided the technical direction, how did we actually go about doing this? So we decided that we would take 12 weeks and we would take a real problem in the business, in the current data environment, right? So we picked a line of business that's having a lot of issues producing the key metrics that were required by the executives in a timely fashion. We decided to take that slice and move it to the new platform. So we had to do a few key things, and one of the key things that we wanted to do was demonstrate immediate business value, right? Not just that we could migrate the data, but that this could lead to sort of additional insight that wasn't available before. We also made a key decision that we were not going to buy an ETL tool, right? We were not going to buy a CDC tool. We really wanted to see how far we could get with the native AWS data stack and open source. And today that Werner, when he announced Glue, I felt very vindicated in that decision. So the outcome of this 12 weeks was we developed a core framework for migrating data. And this, for us, was the central problem. How do you get data out of an AS400 system, which doesn't really talk to anything, into Redshift? That, for us, was the core problem. And we built a framework that allows us to do that in a performant and repeatable fashion. And Lakshmi is going to talk about that a little bit more in a bit. We also validated that we could move from an ETL based environment into an ELT-based environment, and that would work well. And finally, we wanted to show that once we had this data available, quickly, we could also visualize it, and that drive additional insight to the business. And so we used Tableau for that purpose. So a very quick high-level view of the architecture. So in designing the new architecture, we had this imperative that we set for ourselves, that we are not going to persist the data in multiple layers over and over again, pre-aggregated unnecessarily. We're going to keep the data in a relatively raw format. And so we did that in S3. And we would project that data through into the form that we needed it using tools like Tableau. So we did aggregate the data when we needed to, if there was an actual need. We still built facts and dimensions as we needed. This is still a data warehouse. But we did not want to, we wanted to eliminate the need to build a data mart, or the equivalent of a data mart, right? We wanted to eliminate the need to have a cube, or the equivalent of the cube. So I want to point out a couple of key features of this, and then I'm going to hand over to Lakshmi, who's going to talk about the ingestion framework in a little bit more detail. So the first sort of the second key decision we made was that, starting on the left here, if you look at our source data, we decided to bifurcate that feed out of the AS400 staging systems. So the AS400 systems would continue to feed the existing SQL Server reporting environment, but we'd also branched off a feed into the new environment. Over there, you can also see Control M. So Control M is our enterprise job scheduling software. And we wanted to make sure that we integrated with that right off the bat. We're going into production. We want to make sure that all the production folks are aware of all the jobs that are running, and so that we would have the right level of support. And the final sort of thing that I want to point out at this point is we leveraged EMR and Scoop as the heart of our data ingestion framework. So Scoop, if you're not familiar with it, is an open source data movement utility. Using it against EMR allowed us to parallelize this. So we were able to pull data in parallel from the source system and ingest that into our environment, which we named the Scholastic Data Cloud. So I'm going to pause this story. I'm going to hand over to Lakshmi. Lakshmi worked with us as the principal architect and engineer. He built a lot of these components that he's going to talk about now. And then I'm going to continue and tell you where we are in our journey at the moment. So thank you, and I'll be back. Thanks. Okay.
Good morning, everyone. This is Lakshmi from North Bay Solutions. So while Ali was covering about the business driver, why they made the change or shift to the newer environment in AWS with Redshift, and also some of the project-related information. So starting with a 12-week project and what are the possible outcomes, what are the decisions that were made to actually be part of this 12-week engagement. I'm going to cover the technical side of it, what exactly we did as part of this pilot, and what was the core framework. I'm going to talk about the core framework itself and how the project evolved. So you heard Ali mentioning about the thousands of workloads. The complexity of this environment is not on the sizing of data. It's 20 terabytes, but the complexity is in the 5,000 plus or 6,000 plus workloads. The workload for Scholastic, the definition is any change that happens to an individual table is called a workload. So they made it in such a way that it's all well orchestrated. So may change this table, and then after this, do this, do this, do this. So they heavily use a on-premises scheduler called Control M, which orchestrates all these 5,000 plus jobs that run every day during the batch window. So the key here when you're designing in the newer environment is how do you define all these dependencies, how do you categorize these jobs into different job groups, which is basically a functional unit, and how do you integrate with your scheduling that's already happening on premises, and while this has been happening in the hybrid environment possibly for 1-2 years, how do you make the hybrid work with all this orchestration and the dependencies. So defining jobs and job groups was critical. Everything has to be parameterized. So we selected DynamoDB for that. It's ideal for schemaless type of environment. You provide all the information necessary to process a specific workload, be it coming from different types of sources. In this case, AS400, and there were use cases where they were pulling from FTP server. So different types of sources and different types of targets. So DynamoDB was the perfect solution. In terms of the scheduling, so that's another key component. Again, we had to do a lot of whiteboarding and figuring out what exactly should we have one orchestration tool versus multiple. They are using Control M heavily, so we don't want to change that because it has many more thousands for their on-premises environment. With respect to native AWS tools, Data Pipeline provided that orchestration feature. We use that heavily. And I'm going to talk about during the transformation portion, we also had to build a lightweight orchestration engine in Python. And so the combination of three, we were able to execute the overall pipeline right from extraction all the way to transformation. Again, Ali also mentioned about the key non-functional requirements. It's not just providing the self-service capability to the business users. From the IT perspective, it has to satisfy all the non-functional requirements that they already have and they would like to achieve. So having the security, governance, scalability, audit capability, traceability, everything is critical as much as providing the case for the business users. So in the next section, I'm going to talk about each individual phase. So you have the extract phase and the loading phase and transformation phase. How we did it at Scholastic. Maybe this is something that we learned together. We hear from your talks and you hear from what we do. And so for the extract portion, again, if I have to see between extract, load, and transform, the transformation is the complex one. So extract and load are, again, I wouldn't categorize too easy, but they're simpler compared to the transformations. So for the extraction, the challenge was how do you extract the data from AS400 and make it parallel? So I have got questions from the previous sessions on why do you even have EMR in the picture if you're just moving from AS400 to Redshift? It's relational. The reason we went with this architecture is, again, as Ali was mentioned, we used a tool called a Scoop, which is an open source tool, and that can sit on top of EMR. It can parallelize. You can define the number of mappers or parallel process where it can extract and save it somewhere. And Redshift is very efficient to load the data from S3. So it's not efficient to load the data directly from AS400 to Redshift directly. So S3 is the staging area where you have to extract and put it there. And there are some best practices around how you stage the data in S3. It has to be split, it has to be compressed, and all these different best practices so that you can load the data efficiently and faster. And in terms of orchestration, after the on-premises jobs are scheduled and run, the control M kicks off the data pipeline process, which reads the metadata information of what workloads need to be started, can they run in parallel, what are the things that needs to happen. This is all orchestrated using the data pipeline. In terms of the load, again, load is very easy because you have the data already staged in the format that's efficient for loading into Redshift. All we have to do is the orchestration. So triggering a data pipeline activity, which will run the commands on Redshift. Okay, you have this information in this location, just go ahead and pull it. One of the things we added as part of the extraction process, which is used for the traceability, is we not only dump the entire data, we also add a couple of columns, like the batch ID information, what time it's day, so that we have the ability to track or trace all the way until the facts and dimensions. At what time and what batch loaded this type of data and how it's transformed. So we added those columns at the row level. So every time we pull the data, we add 1 or 2 columns, and it goes all the way until the facts and dimensions. So the transformation portion. So this is the common question where a lot of I think many of you are looking for answers for. How do I transform my logic is embedded into the stored procedures, my logic is embedded in the cubes, I have all these places, and there is not relevant direct match when you're migrating to Redshift. It doesn't support stored procedures, you don't have the cube technology, what do I do? Again, there is no easy answer, so you do have to extract the logic from the stored procedures or joint conditions or your cubes. You have to extract that and put it in a relevant place. And the reason we picked ELT is because most of the transformations that Scholastic does, it's based on the incoming data and also the existing data. So it's more like abstract operations or so the transformation in flight, which is typically the use case for ETL, is not applicable. So we load the data into staging tables and we do the transformations using SQL queries to do that and change and create the facts and dimensions. So the majority of, again, the timeline of the project is dependent on how much transformations you need to do and for how many workloads, how many tables we are talking about. So this, out of all the different processes, this defines your length of the project. And in terms of the process, there are a few things which data pipeline was not able to provide. So hopefully this gets addressed in the later versions of the data pipeline. A couple of things it was not able to do is we wanted to track how many rows got inserted, how many rows got updated, so that we do the operational efficiency and optimization. It was not out of the box. So we built a lightweight Python application, which will again gather as much information and then run this transformation and get the metadata related to that. When you're making the transition from your existing systems, again, any type of systems, Pawan was mentioning that commonly you have 3 types of use cases and to migrate to Redshift. Irrespective of where you're coming from, the single biggest optimization you can do when you are migrating to Redshift is around the schema design. You need to understand what Redshift is good at. Don't go like to like. So if you're using Kimball at Scholastic, they heavily use Kimball. They go by the book. Everything is perfect in the existing environment. But when you're making the transition, the common questions are, okay, it's been working. Why doesn't it work? Because it's a similar database house environment. So understanding how the target system, in this case Redshift, works is definitely important, and definitely do make changes so that it's optimized for Redshift. Again, the concept of lift and shift we'll optimize later. It's while you're making the transition, it's better to put some effort upfront on the schema design so that all your reports and whatever the purpose you're migrating to Redshift is achieved by making this call. So some of the high-level best practices, again, these things are covered much more in detail in the 300 level and 400 level courses. But at the very high level, the changes that worked for Scholastic is around modifying some of the things around the star schema. So we were able to get away from the unique identifiers and use natural keys. And the other one is we moved some of the common used columns and dimensions, move it over to the facts. So whenever you're doing joins, you don't want to join all the time. So if the column is already present in your fact, you just base your reporting on single table, so it doesn't need to join. Again, distribution and sort keys, this is very important. If you're coming from MPP world, you already are aware of how those work. It's basically how do you co-locate the data when you're doing the joins, or else how do you make the parallelization happen if you're inserting lots of rows. The other type of optimizations you can consider is around the compression. Definitely do use compression. The auto compression works great. There are some best practices around do it in dev, make a static encoded table into the higher instances. And one of the other questions we keep getting from the customers is Redshift doesn't enforce primary keys and foreign keys. I'm used to that environment. How do I make it happen? Again, you have to use ETL or the overall process to figure out how that's going to work. But definitely do define the foreign keys and primary keys. It's used by the cost-based optimizer to make the decisions, to make it faster. Again, as is true with any enterprise customer, Scholastic has a very high bar on security and governance. Everything has to be secure in the overall pipeline, right from the extraction portion all the way going into Redshift. So the common practices that we followed, and again, which is typical for any enterprises, is encryption at rest and encryption in transit. So we are using the persistent stores of S3 and Redshift. Again, both allow those encryption, transit, and rest. Scoop allows the encrypted extraction. And the actual passwords for the source systems and target systems are encrypted using KMS. We used a customer managed KMS, and we use IAM roles heavily. You have seen in the previous flow diagrams of extraction, loading, and this one we use EC2 instances, transient EC2 instances, EMR clusters, and we use Jenkins for deploying. We use control M agents. So some of these components have EC2 instances. So we rely on the IAM roles, which has access to encrypt or decrypt using the customer managed keys, and only have the least privileges that particular EC2 can do. So going back to what purpose is this new environment supposed to solve? It was supposed to solve the self-service problem that they're having in their existing environment. The business users should have the capability to do self-service on the facts and dimensions. Not only we were able to achieve that, but we were also able to enable the other folks, and we have the power users can go against the staging tables where they have more visibility than they ever had before. We also have the incoming changes per day, every day, stored in S3. So there is a new avenue that opened up for Scholastic where they can mine the data across what's happening in the sources so that they can make new decisions that they're not able to do before. Again, we were able to enable different layers, and we use different technologies. They have been using Tableau for the power users and the business analysts. For the actual data analysts, again, things change rapidly in AWS environment. So we didn't have QuickSight before, we didn't have the newer technologies before, we didn't have Athena before. So we tested with the EMR, Presto, Hive to enable that. And I want to make a quick mention. While we were going through this process, AWS, again, Redshift and all the different components, there's so many updates. It's not the architecture that you started with. You always need to keep up with the pace so that you leverage all the newer features that keep coming. One of the things I can share is when we were doing the initial project, the WLM queues, which is the workload management, it was not dynamic. We had to reboot whenever we are starting the window if we have to use that feature. Again, while we are doing that, that feature came in handy. So now we have a script that basically dynamically changes the workload so that we allocate most of the resources to the batch process, and that the batch process runs efficiently. So keep looking out for all the updates and see if you can leverage in your environment. So once we have this core framework or the overall process data pipeline process defined, this gives a snapshot of what happens in each of the sprint. Scholastic is very big on agile methodology for project implementation. Once we define that during the 12-week project and the later phases, so they follow 2-week sprints. This gives a snapshot of what exactly happens in the 2-week sprint. In the 2 weeks, depending on the velocity of the team identifies what are the things that we can achieve in these 2 weeks. Can we get 4 different new staging tables? Can we add 3 more columns in your dimensions? Can you create a new dimensional fact? So this is defined at the beginning of the sprint, and the actual work effort is basically once you identify what those tables are, define them, add entries into the DynamoDB table, and everything is parameterized. And the biggest component here is the transformation portion, as I was explaining. For those 4 tables that were identified, what was the logic used in AS400, what was the logic used in SQL Server, and convert that specific piece into the newer environment. Create the SQL script around that, and then stage that SQL script in S3, and have the orchestration process run that S3 script as part of the transformation ELT process. And we used the development, test, and deploy in the 2-week sprints. So this was very effective and efficient as we went along through the process. So some of the key technical lessons learned is, as I was mentioning, the core framework, which is the overall process. We envisioned it as something that's almost static, that rarely changes for your overall project. And the actual project repository is something that happened per every sprint. So the 4 tables got changed and the SQL scripts, those are the only things that changed. The DynamoDB, SQL Scoop, EMR, and all the automation around that, it doesn't change. That's the core framework. During the first couple of phases, we had everything as part of the same code repo. We were having some issues as we were not able to scale across teams. So we isolated the core framework with the actual project repository. And as you can see in the environment, you have different layers. And as part of the non-functional requirements, we had to gather all the logging information, all the tracing information, so that we can optimize our process. Some of the information is residing in Redshift, some of the information is residing in Redshift, some of the information is residing in DynamoDB, some is in S3 log files. So there has to be a way of consolidating all that information so that you can run some reasonable reporting so that you can optimize your process. And one of the things, again, if you ask us, what would you do differently if you start right now? So initially, because this was a pilot project, we made some assumptions, and we wanted to do a quick delivery of the actual MVP of the product that we were doing. We did not do the QA automation in the beginning of the project. So again, as it got more successful, we were able to onboard new functional areas, and QA remained a backlog. So it took time for us to actually catch up with the automation of QA. Again, if we were to do that differently, I would start with the QA automation, the test-driven development right from the beginning. So that's it. I will hand over to Ali for continuation. Thanks.
Thanks, Lakshmi. Okay, so I want to take you back to when we were talking about the initial 12-week project and what happened after that. So, that was seen as a success, so that was good. And, when we started that, the management had asked us to come up with a timeline and a plan to migrate the whole enterprise to this platform. So we had estimated a 24-month period, which we thought was quite aggressive, given that we're talking about the whole enterprise, we're talking about years and years of data and complex logic, and 7 quite distinct lines of business. Of course, that was not good enough for them, and they asked us to collapse that to 12 months, which is really aggressive. So there are a few reasons for this. The first is, we had demonstrated in that 12 weeks some immediate benefits to the line of business, right? They not only now had their data hours before they previously did, where they were to meet and beat the SLAs very comfortably, but they were able to visualize and now get a level of insight that they weren't able to do so before. So there was an appetite for that. Also, of course, nobody wants to be running 2 platforms, or in our case, 3 platforms simultaneously for longer than necessary. So we really wanted to collapse the time that these 2 systems are running, at the same time, right? So the final thing was, and this was a good problem to have, a lot of the users were getting wind of this, and we had a lot of comments like, why is LOB X on this and we're not? And that's a good position to be in, of course. So our immediate concern in collapsing this timeline was, well, where are we going to find skilled staff, right? Where do you find people who know AS400 and SQL Server and Amazon Redshift? So we worked closely with our consulting partner, North Bay, and we co-designed a sort of a curriculum and a training program so that when folks were coming on board, they already had the skills, and that helped a lot. So how do you scale up a project like this? How do you go from one work stream, one team working on one line of business to 7 teams working on 7 lines of businesses, and all independently being able to execute a migration like this, which is quite complex? So the first thing is, we had to develop, a cost model for this, right? That's the first thing that you get asked by your management. How much is this going to cost? So we had a fairly decent handle on the AWS costs. We were able to extrapolate that for this line of business, which has this many entities and this amount of logic, roughly, we need X type of environment in AWS. And of course, there were, it wasn't an exact model, but it was a model. It allows us to kind of extrapolate. And we did a similar process with the labor side as well. So we were able to say, okay, if you collapse the timeline by this much, that means you have to parallelize these additional streams, and the cost would be, X. And of course, running in parallel now, having several teams at the same time, we needed help. So we reached out to Agile coaches, and they were really instrumental in getting us to be able to scale our teams effectively. There's also a technology side to this, right? And we needed to make sure that our core framework could stand up to the load that we put on it, and it was designed from the outset for parallelism, but we needed to test that it would scale. So we tested it with 10 times the scale of data passing through it, and it didn't croak, and so that was encouraging. We also needed to increase our skills in engineering best practices. So we needed to make sure that people were using code repositories consistently across these 7 teams, and also we needed to build our continuous integration and continuous deployment frameworks. So where are we now? So we are 6 months into this 12-month migration cycle, and we have migrated 4 out of 7 lines of business. The framework is the secret sauce, right? It allows us to migrate data from our legacy systems into the Scholastic Data Cloud much faster than would have been possible otherwise. One example that I like to highlight is for one of our international divisions. They actually did not use the existing enterprise data warehouse. They contracted to a third party, a different company that they paid hundreds of thousands of dollars to every year to collect their data and manage it and provide reporting and so on. So within only 10 weeks, we were able to migrate them completely away from that vendor, which was AS400, into the Scholastic Data Cloud and sever that relationship and save them about $400,000 or $500,000. So that's very significant. In terms of costs, we now have a very fine handle on the amount that we're spending for our operations. We know, for instance, that the framework that Lakshmi described in some detail costs us, minus the cost of persisting the data itself, about $40 a day to run, right? So we can get that granular, and we think we can even collapse that down by moving to more serverless approaches. We also managed to launch, while we're doing this migration, our first big data initiative. We have a product that is a subscription-based service that's in the schools. So the school subscribes, and all the children who are in that class have access to a library of books that they can read on their e-reader now. And so we have a tremendous amount of data now that we didn't have previously. So we see what the children are reading. It's really kind of fascinating, actually, to see how they read, how they interact with this product. And so we get millions of events that come in every day. An event is the child turned a page, highlighted a word, or so on. These come in semi-structured JSON format, and we're able to process those as well. So, one of our lines of business that has moved over now to the Scholastic Data Cloud, we're processing millions of rows a day, and we actually have to reprocess about 1.5 billion rows daily to get a fresh view, and that we're able to do without breaking a sweat. In terms of our ETL and now ELT cycle, we've managed to improve the performance by over 170%, which is very significant, and we still think there's a lot of room for improvement there as well. So, key lessons that I would share with you if you're thinking about migrating, things to think about, have an absolute clear view of the costs in your environment, right? Monitor them closely and think about, moving to serverless approaches wherever possible. So one of the things that we're doing now that we didn't do previously is, spinning up EC2s when we need them and popping them out of existence when their work is done. The second sort of key takeaway is, this is not if you build it, they will come, right? Going back to our original goal of, having self-service reporting, it's really key to engage the business, right? You tell them, okay, we're on Amazon now. So they say, oh, great. So can you write me a report? Well, no, right? So it's really key to have that relationship with the business. And the way that we did that was, identifying in every line of business a person that we called a data champion. So the data champion is someone who's an expert in data, not a technology person, but then we partnered them with a technology person on our side, a data guide, and these two people together in every line of business really, work together to define how adoption should work. Agile coaches are really key if you're going to do a project like this with multiple teams at the same time, and that was very important for us. As is choosing, the right partners, people who have experience in doing that. So we were very lucky on that account as well with both AWS Consulting and North Bay. And finally, the most important lesson is nobody wants to be running multiple systems at the same time, right? Standing up a new environment, especially with technology like AWS, is easy, right? Even migrating your data, that's not a very complicated problem. That's a solvable problem. But decommissioning an existing system is it's extraordinarily hard, right? We knew it was hard, and it was still harder than we thought it would be. Having said that, we are on track to migrate the rest of our enterprise within the next 6 months to the Scholastic Data Cloud. So with that, I'd like to close. My co-presenters and I are available for questions, and please do fill out the session evaluation. Really appreciate your feedback. And thanks very much.